This is start from the first here. I'm talking about acids and alkali, and this is topic number 8 in your syllabus. And we will divide topic number 8 into four different sections. First one, introduction. We'll talk about it here. Section 2, reactions of acids and alkali. Section number 3, making salt. Section number 4, oxides. You can define acid as proton donor, For example, here, if you have HCl, hydrochloric acid, will dissociate to form H positive plus Cl negative. H positive plus Cl negative. H positive is a proton. H positive, this is a proton. So definition of acid is proton donor, according to Cambridge definition, proton donor. Acid turns litmus red. If you have litmus paper and you put litmus paper inside acid, color of litmus paper will be red. As you see here in the slide. Color of litmus paper will be red color. Here I have different examples of acid: HCl, hydrochloric acid, H2SO4, sulfuric acid, HNO3, nitric acid, CH3COOH, acetic acid. You will notice here I have H in H2SO4, also I have H in HNO3, I have H, even here I have H. So these compounds are acids. I have two different types of acid. Number one, strong acid. And you ask it to define strong acid. Strong acid, that's mean completely ionized. What does it mean, completely ionized? Strong acids completely dissociate in water. Here in this example, if you have HCl, as you see here, there's a bond between H and Cl. You can see the green line. This is the bond between H and Cl. This is HCl. Even here, I have HCl. Here, I have HCl. Here, HCl. Okay? If you add acid to water, acid completely dissociate in water. Look here, H alone, Cl negative alone. Cl alone, H alone, Cl alone, Cl alone, H alone, H alone. So 100% ionization, HCl completely ionized, completely dissociate to form H positive and Cl negative. So you cannot see here HCl. You cannot see H connected to Cl. You cannot see H connected to Cl because HCl completely ionized. So this is strong acid. So if there is a question, if I ask you a question, sulfuric acid is a strong acid. Why? Because sulfuric acid completely ionized. Hydrochloric acid is a strong acid. Why? Because completely ionized. Because hydrochloric acid completely ionized in water, or completely ionized is correct. What is the meaning of strong acid? Completely ionized. What are different kinds of acids? Number one, strong acid. Completely ionized. So if you have strong acid, this means you have weak acid. Weak acid partially ionized, like CH3COOH. Okay, so different kinds of acid. I have strong acid, which is completely ionized, completely dissociate, and weak acid partially ionized or not completely dissociated. This is what I need to say about acid. So acid is proton donor. Can you give me examples of acid? Yes. HCl, hydrochloric acid. H2SO4, sulfuric acid. H3PO4, phosphorus acid. CH3COOH, acetic acid. What is the color of litmus paper inside acid? What is the color of litmus paper inside acid? Red color. What are kinds of acids? Strong acid and weak acid. What does it mean, strong acid? Completely ionized. Weak acid, partially ionized. Now I'm going to talk about alkali. Alkali is a proton acceptor. It's a proton acceptor. So you have to remember, acid is a proton donor. Proton donor means it will produce H positive. HCl, the CCl2 form, H positive plus Cl negative. So this is acid. But when I talk about alkali, is a proton acceptor. Proton acceptor. What does it mean, proton acceptor? It will accept hydrogen, to accept hydrogen. In this example, base is a proton acceptor or alkali. You have NH3 here, NH3 plus H2O. Look in the product, NH3 became what? NH4. NH3 became NH4. What does it mean? NH3 gain hydrogen, gain hydrogen. So instead of NH3, it will be NH4, NH4. So I can say NH3 is a base, NH3 is alkali. Why? Because it gain proton, it gain proton. It can gain a proton from water. So NH3 plus H2O will form NH4 plus OH. Here, it was NH3. After gaining one hydrogen, it became NH4. So this is proton acceptor. Proton acceptor. Here, you can compare between definition of acid and base. When I'm talking about base, exactly when I'm talking about alkali. So I can say that, all that. Acid is a proton donor. Acid is a proton donor. So in this equation, we can say HA give hydrogen to H2O. So HA is acid. Here, base is a proton acceptor. Proton acceptor. So we can say NH3 is a base or NH3 is alkali. Why? Because it accepts proton or accept hydrogen positive. Exactly. In different type of base, it's exactly like different type of acids. We said we have strong acid and weak acid. Strong acid completely ionized, weak acid partially ionized. So kinds of base, strong base and yes, weak base. Strong base and weak base. Or strong alkali and weak alkali. I can use the term base or I can use the term alkali in definition. Okay. Strong alkali completely ionized, weak alkali partially ionized. Example of alkali. Actually, alkali must contain OH group, hydroxide group, like NaOH, sodium hydroxide, LiOH, lithium hydroxide, KOH, potassium hydroxide, CaOH, CaOH by 2, CaOH by 2, calcium hydroxide. You will notice here I have OH group. In sodium hydroxide, I have OH group, so this is alkali. In lithium hydroxide, I have OH group. Even here in potassium hydroxide, I have OH group. Even here with calcium, I have OH group. Okay, so in alkali, must contains what? Must contains OH, OH, OH. Alkali must contains OH, NaOH, KOH, LiOH, CaOH, FeOH by 2, okay, AlOH by 3. Whatever you have, if there is OH, this means you are talking about alkali. You are talking about alkali. So alkali, different types of alkali we said, strong and weak alkali. Strong completely ionized and weak is partially ionized. Or dissociate, you can see the both there. Okay. What about indicators? What about indicators? Actually, in this topic, you have to know 3 different kinds of indicators. 3 different kinds of indicators. Litmus paper, phenolphthalein, and methyl orange. Again, litmus paper, phenolphthalein, and methyl orange. What about color of litmus paper in acid? If you have litmus paper soaked in acid, what is the color will be? Will be red. So color of litmus paper with acid will be red. Color of litmus paper with alkaline solution with alkali will be blue. Will be blue. Phenolphthalein. Phenolphthalein, actually this is a solution. If you add drops of phenolphthalein inside acidic solution, the color will be colorless. Colorless. There is no specific color. Colorless. Nothing will happen. But if you add small drops of phenolphthalein inside alkaline solution, the color will be pink. Pink. So again, litmus paper with acidic solution will be red, while alkaline solution will be blue. Phenolphthalein with acidic solution will be colorless, while alkaline solution will be pink. Finally here, methyl orange. If you add drops of methyl orange into acidic solution, the color will be red. If you add methyl orange, stop please. If you add methyl orange inside alkaline solution, the color will be yellow. The color will be yellow. So you have to remember these colors. You have to remember these colors. Litmus in acidic red and alkaline blue, phenolphthalein in acidic colorless in alkaline pink, methyl orange in acidic red in alkaline is yellow. If you need to remember here, what is this? Orange. Orange. And actually, if you add red to yellow, will give you orange color. Will give you orange color. Okay? Will give you orange color. Here I have pH scale. pH scale. What does it mean, pH scale? pH scale, I have from 1 to 14. From 1 to 14. This is a scale from 1 to 14. You will know from this scale you have acid or you have alkaline solution. Actually, before 7, you have acid. If pH less than 7, so you are talking about acid. If pH more than 7, you are talking about base. If 7 exactly, so you are talking about neutral solution. Neutral solution. So pH scale start from 0 to 14, from 0 to 14. Less than 7, less than 7 acid, more than 7 base or alkali, 7 exactly, this is neutral solution, neutral solution. And the lower pH you have, the lower pH you have, more acidic solution, more acidic solution. So if you have pH 1 and pH 6, if you have pH 1 and pH 6, both are acids, both are acids. Which one is more acidic? Which one is more acidic? 1 or 6? Yes, 1 is more acidic. 1 is more acidic. Why 1 is more acidic? Because the lower pH, more acidic solution, more acidic solution. If you have pH 3 and pH 4, if you have pH 3 and pH 4, which one is acidic? Both are acidic solution. Both are acidic solution. Why? Because both are less than 7. Less than 7. Which one is more acidic? pH 3 or pH 4? pH 3 is more acidic. pH 3 is more acidic. And regarding base or alkali, higher pH, more alkaline solution. Higher pH, more alkaline solution. So if you have pH 11 and pH 14, pH 11 and pH 14, which one is basic solution? Both are basic solution. Why? Because both more than 7. Because both solutions are more than 7. Which one is more alkaline solution? pH 14. pH 14. So in pH scale, you start from 0 to 14. Less than 7. Less than 7. This is acid. 7 exactly. This is neutral solution. More than 7. More than 7. Alkaline solution. The lower pH, more acidic solution. Higher pH, more alkaline solution. Lower pH, more acidic solution. Higher pH, more alkaline solution. pH 9 and pH 11. pH 9 and pH 11. Both are alkaline solution. Both are alkaline solution. Which one is more basic? Which one is more alkaline? pH 11. pH 11. Okay, so this is pH scale. pH scale. By pH scale, you can detect you have acidic solution, neutral solution, or alkaline solution, Even here, we have something very important. Universal indicator, universal indicator. And universal indicator, actually, universal indicator is a mixture of dyes, is a mixture of dyes. It can be used as a solution or paper, as you like. If you need to use universal indicator as a solution, that's your choice. If you need to use universal indicator as a paper, so that's your choice. But in all cases, it's color change with pH. It's color change with pH. What does it mean? If you look here, you can see universal indicator pH color chart. If you have this color, what does it mean? Red color, the first one. This means you have acidic solution, or the pH 3 or less than 3. 3 or less than 3. If you have this color, the last one, what does it mean? Yes, pH is equal or less than 10. This color, what does it mean? pH is 6, okay, and so on. So in universal indicator, pH will change according to the color. You can see here in this bottle, you have universal indicator, Universal indicator pH color chart, as you see here. These colors are acids. In the middle, as you see here, green color, that's mean neutral solution. Dark green here, and the last, this is base or basic solution. So this is basic solution. Sometimes inside in the chemistry lab, you can see this picture. What does it mean? Corrosive, corrosive. There are many questions in IGCSE exam about this picture, especially in paper 6, alternative to practical. We will ask you about this picture, so you have to remember this picture very well. This picture means corrosive, corrosive. Corrosive, what does it mean? It can burn your tissue. It can burn tissue of living things. It can burn tissue of your hand, as you see here. So acids and alkali are corrosive substance. Corrosive substance. What does it mean, corrosive? It can burn tissue of living things. Here we need to compare between a strong and weak acid and bases. We said strong acid or strong base completely ionized, weak acid or weak base partially ionized. In the first picture, in the left, you can see here, strong acids are completely ionized. For example, imagine here you have HCl, so HCl, 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 and so on. So every atom is alone. Every atom is here, is alone. But here in the second picture, you can see weak acid, partially ionized, partially ionized. Here you have the acid, okay, the red ring with the blue circle here. Some of them dissociate. Look here, it exists alone. Here, it exists alone also, but here, connected together. So some of molecules ionized, some of molecules doesn't ionize like that. So strong acid completely ionized, weak acid partially ionized. As we said before, acid contains hydrogen, alkali contains OH group. For example, here you have HCl, HCl hydrochloric acid, hydrochloric acid, it will dissociate to form H and Cl, hydrochloric acid. Sodium hydroxide will dissociate to form sodium and OH group, OH group. And you cannot break down here between OH. So it's very difficult. HCl dissociate to form H and Cl. Sodium hydroxide dissociate to form Na and OH. So that's what I need to say about acids and alkali. Again from the first here, as you see, acid is a proton donor. Turns litmus to be red. Proton means H positive. Example of acids: HCl, H2SO4, HNO3, CH3COOH. Types of acids: I have strong acids. Strong acid means completely ionized, as you see here. HCl, completely ionized to form H positive and Cl negative. 100% ionization, 100% ionization, H positive and Cl negative. Weak acid partially ionized. Base or alkali, proton acceptor. Proton acceptor means it will gain hydrogen. It will gain hydrogen. NH3 became NH4, so it gains hydrogen, became NH4. Again here, acid proton donor, base proton acceptor, proton acceptor. Types of alkali: strong alkali and weak alkali. Strong alkali completely ionized, weak alkali partially ionized. Example of alkali: sodium hydroxide, calcium hydroxide, potassium hydroxide. So you must say the word hydroxide in alkali. Different color of indicators: litmus with acidic solution, red, alkaline blue, phenolphthalein colorless and pink, methyl orange, red and yellow. pH scale starts from 0 to 14, less than 7 acid, more than 7 basic solution, 7 exactly neutral solution. The lower pH, more acidic solution, higher pH, more alkaline solution. Universal indicator is a mixture of dyes. It can be used as a solution or a paper. Different colors of neutral or of indicator, universal indicator in different pH, as you see here. This picture means corrosive. Corrosive means it can burn or damage. It can damage tissue of living things, like tissue of your hand, for example. This is what I'm trying to say about first part from topic 8 in your syllabus. Topic 8 is acid, base, and salt. As I said before at the beginning of the session, we will divide topic 8 into the first part. I talked about it now. Second one, reactions of acids and alkali. Third one, making salts. And finally, oxides. Thank you for listening. Now I'm ready to receive any question from anyone of you.